Okay, well, welcome back, and so this is going to be part 9 of the video series for making the water piano box. So in the previous videos, we made our parts, assembled our parts, and made sure that they fit together properly. And so in this video, we're almost ready to 3D print, but not quite yet. We need to do one more step, and that's called slicing. So we need to slice these solid shapes into layers so that our 3D printer knows what to do layer by layer as it's laying down the liquid plastic. So what we're going to use for that is a program called Tinkerine Suite 2. So I'm going to load it right now just because it takes 20 seconds to load up. And so there's another step that we got to do with our two part files here. So what we have to do is export them as a different file type because Tinkerine can't read DWG or .ipt or anything like that. So we need to do a CAD format. And so what we're going to be saving these as is a .stl. So STL is it's a pretty old file type where 3D models have been made by this. It's sort of the default file type for 3D printing. So if you wanted to get a model from the internet, like say, model plane or something like that, and you wanted to 3D print it, it would probably come as a .stl file. So let's save that, and well, yes, okay, we'll replace it. And we're just going to do the same with this part here. So export as a CAD format, make sure it's a .stl file, save that part. Sure, I'll replace it. Okay, so now Tinkerine is opened up. So this square that you see here, this is basically the bed of our 3D printer. So how we're going to start, we're going to hit File, and we're going to import our model. So you got to navigate probably to the place where you saved it. So I'm in the water piano videos folder. Open this up, and so there's our part. So for whatever reason, Tinkerine likes to open our parts up sideways, even though we made them flat down in Inventor. This is the bottom here that's facing us. So we need to grab this green axis and swing it around so that our top's facing up. Because this is really important when we're 3D printing, because if we're going layer by layer with some liquid plastic, just imagine we're trying to, well, extrude it way up here. Let's say it's 2 inches up high, so maybe if we flip this over a little bit more, okay, and you see, how our sides, there'd be nothing underneath it there. Well, there would be nothing to lay the plastic layer down onto. So we made our part so that all of the parts go right up and down, so that we can do it layer by layer without having to do any fill in the middle. So we got to lay it somewhat flat here, and then we got to hit this button that says Lay Flat, so it actually lays itself perfectly flat. If we don't do that, then we're going to try to print the thing on a bit of an angle, and then it would end up all wonky. That wouldn't be good. You can move it around if you like, so it's sometimes good to not print always on the same part of the bed, so you can move it here, you can move it there. If everyone moves it somewhere else, then we end up printing on different parts of the bed, and we don't get a bit of, a whole bunch of gunk building up in the same middle part of the beds everywhere. So I'm going to put mine right here. That works, okay. So now let's go through a few of the settings that are up here. We don't really need to change a whole lot, but I'll just explain what they do. So the resolution, basically that means how much plastic it's going to extrude at once. So we're just going to use a low setting because, well, this is a box and it's holding something. It doesn't need to be super pretty, and what we're really aiming for is time, because if we did this on the ultra high resolution setting, then this would take like 12 or 15 hours to print, and we can't have that because there's a whole class full of people that need to print this. So we're going to keep the low resolution. The sparsity, so basically inside the walls it doesn't actually fill in with plastic all the way inside. And there's a couple reasons for that. You don't want to use too much plastic if you don't have to, and as the stuff cools it starts to warp a little bit, so it's actually better to make some walls and fill them in. So if we did it hollow, there'd be no fill on the inside of the walls, and the two walls would just have nothing holding them apart, so that'd be bad. If we did it dense, and it would take a whole lot longer to print it, and it would be heavier and use more plastic, so let's stick to sparse. So this is the amount of layers that we're going to make the walls out of. So again, if we did it with 4 layers around the wall, that'd be, well, probably thick enough that we wouldn't have any infill on the inside of the walls. So let's just keep it on 2. Supports, that's what we would need if we were trying to print something, you know, like if our side was way over like this, we would need some support to support that stuff. So let's just put this back and lay it flat once again. Okay. So the filament diameter probably shouldn't change, 1.75 millimeters. The printing speed and the temperature, so these are basically dependent on the machine, and they're probably set to where they need to be. So let's hit the slice button. So if you need to rotate around, you hit the right mouse button and that rotates it for you. You shouldn't really need to rotate much because we're not doing much in this program. Thinking, there we go. So now you can see it's building up the layers of plastic layer by layer. So this is basically just taken our 3D model and it's sliced it into individual layers, and it's going to spit out what's called a G-code, which is a type of code which tells the motors in the 3D printer, okay, now you need to go along the x-axis this way, and then you need to go on the y-axis this far, and then you need to go back and forth this way. So let's save this. Let's save it to the computer. And so we're going to save that, I guess, because I already made this before. Let's replace it. Yep, okay. And, oh yeah. Well, at any rate, save it to the computer, and then we're going to find some SD cards next to the 3D printer. Go grab an SD card and transfer those files from wherever you saved it on the computer onto the SD card. And so I'm just going to do the other one here as well. Import model file. Well, I actually want to clear the bed, so would you like to continue? Yes. So with this one, the top, what we need to do, because we got these the fangs coming out the top and the cylinder for our screw mount up there, we're going to spin it this way and lay it flat. And this actually does a nicer job because the bottom layer of the print turns out with a fairly good surface finish, and the top ends up just a bit bumpy and a little bit ugly. We're not going to see that if it's on the underside, so that doesn't matter. So all of our settings are the same. Let's slice it. Can we save this one? Or are we going to get another error message? Let's change the name of it. Maybe that'll make a difference. Save. That one saved. Okay, good. So that was basically it. So we have now sliced our 3D model and we've made a G-code, and the G-code is what you use to actually 3D print it. So all you got to do now is put the G-code onto an SD card, plug it into the 3D printer, and go through the menu until you find your file, and then hit print, and that's basically it. So that concludes the series of videos of how to make the water piano box. So thank you very much for watching. I hope you learned something. I hope you are inspired to use Inventor to make more 3D parts. And of course, once you start 3D printing things, you'll find that it gets quite addicting. So I got a funny feeling that you'll be back. So thanks everyone for watching, and I hope your project goes well.